Hello, everyone. Welcome to the Data Science Mentor session, Accelerated Learning Cohorts. My name is Pablo, and I am the founder, convener, and host of the Data Science Mentorship Cohorts. This is a pilot cohort, and today we're in the final part of this pilot cohort, which we are covering introduction to machine learning. The last time out, if you haven't seen the first session in machine learning, you should check it out. It's on introduction to machine learning, and we didn't write code in any way, shape, or form. We wrote a little bit of code just to visualize an image, but that's not like serious code writing, right? So today we're going to be introducing the Scikit-learn API, right? So it's important for us to, I think this aspect of machine learning education is really important. I think a lot of learners skip this phase. Two phases I think are typically important: learning numerical Python, understanding numerical Python, the intuition behind numerical Python, arrays, and how to use arrays and array routines to understand or present data or analyze data, right? And then the understanding how to use a Scikit-learn API, fundamental stuff. And also generally moving on from the Scikit-learn API to, building a simple model. There's almost, I hear it a lot from learners where they just typically say, oh, I don't understand why I get this error that the API cannot either fit the data that's been shared. And that's because the idea of how the Scikit-learn how the Scikit-learn API summarizes tables, for lack of a better term, it's stuff, or no, rather what it means is the data representation by Scikit-learn is lost on a lot of learners. And I think that is what we're going to cover today. And if we have more time, we can go on to do simple models, build simple models, and then see how the Scikit-learn API is used. If that's not possible in today's session, then it will be in the third session. Right, so this is the second session that we're starting out. Right, please feel free to ask questions while we're at it. I am going to explain things as slow as possible and then try as much as possible to share the analogies that come with it. All right, so today we're looking at the Scikit-learn API. You hear in some courses, you hear them call it sklearn, but yeah. Now, Scikit-learn is one of the best known packages for efficient, it's efficient for a large number of machine learning algorithms, right? Now, sklearn, or rather, Scikit-learn is known for, one, clean, is known for clean, it's known for uniform, it's known for clean, uniform. Another word I'll typically want to use is organized. Clean, uniform, and organized APIs. Right. Now, another cool thing it has is it has an updated documentation. Right. And all these things, the benefit is for you to build a simple model, for you to build a simple machine learning model. And because it has a lot, it has an updated and a very robust documentation. Understanding how it's organized and streamlined makes a lot of sense for anybody that is getting started with machine learning, right? One thing we're going to I must achieve, one of the learning objectives for today is for learners to get a solid understanding of how these APIs work, right? And the hope is that we go from a foundational to a deeper practical understanding of the machine learning algorithms and the approaches that are used by scikit-learn. Right, so the first thing we're going to do today is we're going to look at how data is represented in scikit-learn. It's super important. So again, I'm going to start off with a question. How is data represented in scikit-learn? Now, ML is about creating models, right? And I think it's important that we understand what creating models is. You have an activity that happens regularly, and you want to find that a very simple equation or model that can be pulled out from that data, which is sort of, the secret sauce to whatever happens. And if a new activity happens, then you can throw in that model to that data and to make sense of whatever you wanted to achieve with the initial model. Right now, because it's important, because data is important in this sense, and the data we get, the raw data we get from life, right, has to be represented in a way that works with sklearn for you to achieve what you're looking for, right? So one thing we have to think about sklearn is we have to understand how data is set up in sklearn, right? Now, in sklearn, we have to think about the data in terms of tables. So let's put this. We have to think about data in sklearn. I keep saying sklearn, scikit-learn, scikit-learn, data in scikit-learn, like tables. Now, a table is a two-dimensional grid of data. That's what it is. So a table in an sklearn. Did I just say sklearn? I wonder, like, it tells you just how old I've been in this business. A table in scikit-learn, right, is, I prefer to call it scikit-learn. But I don't know why the sklearn just keeps jumping on me. Maybe because it's just a part of the class in scikit-learn. A table in scikit-learn is a two-dimensional grid of data. It's a 2D grid of data. Now, I want us to basically take this step one step at a time, right? Now, when you talk about a two-dimensional grid of data, you're talking about rows, you're talking about columns, right? So here, rows, we're going to talk about what rows are about. Now, rows represent individual elements of a data set, right? Again, rows are individual elements of a data set. Right, so, and columns represent the quantities of each of these elements, right? So columns are quantities of each of the elements in a data set. Or in a data set, yes. So again, rows and columns. Rows, individual elements of the data set. You can see them, they're aligned, and then columns, are like they represent quantities of each of the elements. Quantities of each of the elements the quantities of each of these elements, right? Each of these elements. Let me take this out. Yeah. Now we're going to make this possible, we're going to look at data, right? We're going to look at data. We're going to use this data to make sense of it, right? We're going to pick out a data, a very simple data, and then at this point, we'll start looking at each element for a start, right? Now, to get started, I'm going to let me create a spot where I'll import my data. So I'm going to start off with importing. Let me import pandas as PD, and I'll import Seaborn as SNS. So I'll run this. So I'll have this in the namespace. Now, if you had followed the Seaborn session, you see that Seaborn has a repository for data sets, right? So if you check out the Seaborn repository, you see that it's a thing. Now you can make use of this data set, right, by basically loading it straight off from the repository itself. So you have to be online for that to work. Now we're going to be looking at there is a data set, the iris data set. The iris data set is a constant feature in machine learning. It is used to explain a lot of things, from the pandas data frame to machine learning algorithms, and we're going to use that too. Right. Again, you can also look up the history of the iris data set. It goes way back into the 30s and the 40s. It was famously analyzed by, as an individual that famously analyzed the data itself. So yeah, so that's what we're going to be using now. For us to do this, I'm going to call this. So I'm just going to load the iris data, and so that's what we're going to use for illustration. Now, a lot of the stuff I'm doing here is basic, is pretty basic. And if you're watching for the first time and you're learning data science for the first time, I'll advise that you take your time while learning this to also understand that there are a lot of fundamentals you're missing out. So if you're still struggling with basic Python, it's ideal for you to also learn that while you watch this. Now, to this end, I would call this iris data. Then I'll say sns.load, which is the data set. And by simply writing iris, you get to call the data set itself. So that means if I have iris underscore data dot head, and you can see that I have we have data here. Now, when we refer to rows, we refer to this. See this? When we refer to rows, we refer to this single observation. Single observation. This is a row here. When we refer to rows, we refer to this single observation. That's what it is, right? And the number of rows you often see it being used saying the number of records and stuff. That's what it is. Now, because we are going to be looking at how data is represented in scikit-learn, we'll refer to these rows here. So we're going to refer to rows. We would refer to rows as samples. Refer to rows as samples. So let's know that we're going to refer to rows as samples. Now, I didn't even know why I put it as this. Let's make it refer to rows as samples. Now we would, if we now want to talk about number of rows, so we'll refer to number of rows as n underscore samples. Right, so this is what we're going to do. Now the next thing we want to look at here, we're going to look at is this: columns. Right? Now the column of the data refers to the particular quantity. That's why I mentioned here, if we go here, you see that rows, individual elements, because individual elements, yeah, of the data set. Columns are the quantities of each of these elements. So you can see them. So that's what we are. So here, I'll go into another cell and we will refer to the columns. So here we will refer columns as features. So let's get to have that. So all these are like these are like our rules. They're like how we're going to get started with them, right? Now we would now look at numbers of features as n underscore features. So we're setting the stage for how to understand. We're setting the stage for how to understand the scikit-learn API and how scikit-learn represents data. Now, the important part is because if we started from the part where we started to look at data intentionally in this cohort, we looked at NumPy, we looked at data as arrays, and we also looked at data as data frames, like two-dimensional rows and columns. Now we're going to take these two together, put them together, and make sense of it. Now, so remember that we mentioned that scikit-learn represents data, right? Has a data representation. Now, this data representation, we're going to now talk about it. I'm going to introduce the concept. I'm not the one the concept. There's a popular concept for looking at data, and it's called the feature matrix. The feature matrix, right? So the feature matrix is basically the table layout for how we can look at the representation of data by scikit-learn, right? So now the feature matrix is going to be looked at as a two-dimensional numerical array. So this is going to be a 2D numerical array. At this point, if you don't understand what a numerical array is, so I'll encourage you to check out Introduction to NumPy. It's a session. It's the second session we had in this cohort. So check it out. It's in you have access to the sessions I had. So please check them out. Now we're going to be looking at the way as scikit-learn represents data as 2D arrays or matrix. 2D array or matrix, right? And that it can also be called a feature matrix. So that is one. Now, it's important to state that when you're learning, there's a convention. Now that convention is normal. During the convention, if you notice, there's a convention of import numpy as MP, import pandas as PD. And there's also this convention of, DF being the very simple way to create data, right? To this end, right, we are going to be, we're going to store we're going to store a few things. We're going to have, because we have a feature matrix here, our feature matrix is going to be our 2D matrix, right? And we're going to store it as X. So which means the feature matrix is two-dimensional, right? So let me put this here. The feature matrix is 2D, and conventionally named X. You'll always see that it's conventionally named X. Now, so the shape of the feature matrix, is going to look this way. It's going to be a square bracket, and we're going to have n_samples. And if I go back to n_samples, we're referencing what? Rows. See that? Then here we're going to have n_features. And so when we say n_features, we are referencing columns. Right. And this is a matrix. So, and when we say it's a matrix, right, it's contained in a numpy array, almost always contained in a numpy array, right? Sometimes it could also be in a pandas data frame. Right, so this are almost ways which we are going to set them up. Though sometimes scikit-learn models will also accept something called sparse matrices, but that's not what we're going to be talking about now, right? So now, but mostly it would almost always be. So let me write. It is almost always contained in an numpy array, or pandas data frame, right? Now, so now we know that the samples, which is a row, right, and the features is a column, right? So the rows, which are the samples, refer to the individual objects, right? The rows, they are the individual objects. You can see them. They refer to the individual objects inside the data set, right? Now, a row, a sample will represent maybe a person, and if it represents a person, it might give a bunch of things about the person. It could be the person's name, it could be the age, it could be a bunch of things. It could be a document, it could be an image, it could be a lot of stuff. So that's why you see the samples, records, right? And so that's, and the features would almost always represent the distinct observation of a person. So say, for instance, there's a row, right? There's a row referencing maybe students. So there'll be a student's age, right? So there'll be the student's age, which age is a column, which is a feature. And but once you put age, you know that we have a bunch of students in the data set. So in row 0, which is like basically the first, if the first student is Pablo, it will reference age, job, location, educational level, and stuff. So you see that as the one sample is a row, you start to see the age, the job, the educational level, income level, and stuff like that. So these are the two things I tried to set up here. So where we have our samples and our features, right? And all this come in different data types, right? So they could be discrete, they could be Booleans, they could be numerical, right? So that is one part I figured I talk about the features matrix. And let me correct this, the features matrix. Now, the next thing we want to look at is called the target array. So here, look at the target array. Now, I'll go back to, just to set this up, I'll go back to this. Now, the interesting thing about the iris data set is it has columns. It has columns. This columns, you can see here we have this feature, which also columns. We have this feature. Now, there's almost always this interesting feature here, which is often given a name. It's often known as a label. It's often known as a target variable. It's often known as a target. Right. Now, these features, because the iris data set is will show the different features of the flower, right? The iris flower, and then you can use it to determine the specific species, right? So you look at the length, the sepal length, the sepal width, the petal length, the petal width, then you can tell the species. Now this is the target, is the array. It's different from this guys. This guys is sort of, for lack of a better term, or like the determinant of what this label is going to be. So it's always called the target array. And in machine learning, from the first class, we talked about the input and the output. These guys are the inputs. And this very guy here, with all these guys here, are the outputs. So the model is in between. So we're trying to build that stuff that should be able to read, ingest these guys, and then predict what this will be. So that's what it is. Right. So now what we're going to be doing is we're going to talk about this target array. We're going to talk about it. And we're going to look at how it is represented to the data representation of this in scikit-learn. Right? So the target array is usually one-dimensional. Right? And of course, if it's one dimension, it's just like as part of the row, it's just one of it, right? Then it is normally contained in a numpy array. Or a pandas series. Now, the target array can be maybe numerical values or discrete classes or labels. So, right, so it can be numerical values or discrete classes. Slash, what's that word again? Classes or labels. Yep. So it could be any of them. Right. Now, remember, inside the target array is going to, it's going to be in that. So, it's going to be, we're going to have our features matrix and our target array. Our feature matrix is going to have this guys inside of it, this guys here, and then our target array is going to have what we are trying to predict. So that's what it is. Now, a common point of confusion is almost how our feature matrix differs from our target array, right? Now, so we will have to talk about this, right? Now, the target array is almost what you want to predict, right? So again, it's the target array is what we want to predict. Recall when we were talking about the email spam detector, excuse me, the target array is spam or not spam. Then the feature matrix is basically the things that it looks at to be sure that this is to confirm that this is to predict that's why these are the variables you look at and say, okay, we look at this and I can predict the target, right? So it is important for us. It's important for us to distinguish these two things. So the target array is what we want to predict. The features matrix are the variables used for predictions, used for predicting or predictions. So these two guys are there. Yeah. So whenever we're trying to build a model, using this as an example, right? We want to predict the species using these guys. Now in statistics, right? Statistically, they have a name, right? Statistically, let me put this here. All right, just say in statistics, it's obvious. In statistics, it's called the independent array, which are the feature matrix. Not an array, sorry, the independent variables. Here, and so these are the feature matrix, features matrix, and the dependent variables or variable is a target array. So that we know that these things are different, right? So that's one thing we want to do. Now, I want I want us to visualize this thing in a way that makes a lot of sense before we now proceed, right? So I'm going to do a simple visual. So let me go back here so like I can now introduce let me see. Let me import matplotlib.pyplots as MP. Oh, sorry, MP. Yeah. So we've added that. Now the reason I had to do this was so I want us to have a visual representation of what we're looking at here. Now recall that we have our data set here, right? So what we're going to do is we're going to create a pair plot that's just going to visualize the whole of the data set. And once we visualize the whole of the data set, we can now point out how all these things all relate to predicting our dependent variable. So what I'll do here is what I have done basically is I'm going to use, let's see, matplotlib inline. That's one. Second, I'm going to say sns.pairplot. Then my data is going to be iris data. I'm going to take the whole of the data. Then I want to place a focus on species. And yeah, let me see if this works. It should work, right? Then plt.show. Just a bit is going to show up, and a bit is going to show up. Oh, so sorry. What did I do? Oh, can you imagine? PLT. You know, at the point when I was looking at that, I was wondering why I put MP. And maybe because I just thought I wanted to put just matplotlib. That's why it was like, what's this? Right? So now let's see if our visual comes out. Right, so you can see what our visual looks like. Now let's look at, let me make this let me reduce this a bit so we can see if we can see everything. Oh, look at that. Now you can see, right? I don't know how this has become so small, but let me just bring it up a bit. Or I'll just basically check out everything one step at a time or one column at a time, right? Now you can see here that we have the sepal length. Now, if I go back over here, you can see this is the sepal length. So this is a feature here. Now you can see that there are different visuals, right? And in all these visuals, there is the representation of the species, which over here is our target array. So everything you have here shows us all we're trying to predict, right? So you can see that we have our sepal length, our sepal width, our petal length, our petal width, right? And again, just you can see how all of them all have a relationship as we go, right? They all have a relationship as we go. Hold on. I'm gonna run this one more time because it seems to be so big. It shouldn't be that big. Just a bit, right? Right, so you can see that. Now, with all this, you can see all the columns, which are the features, right? N_features, right? And this is it. And every representation you see here are the samples, are just part of the N_samples, right? Which make up our feature matrix, N_samples, N_features. Then we now have our target array, right? we have our target array, and of course our target array has numbers of samples inside of them, which will be the same samples as our features. So this is it. So now you can see what we're trying to predict over here. Now, most times it's not almost, it might not be a discrete class. Sometimes it could be numbers. So if it's numbers, it's typically really hard for you to visualize it from this point. Because these are in class, they're in classes, it's easy to check out. So this is basically what we are trying to do here. But now, I want to show you something. Now, if we were to use scikit-learn, we would have to extract the features matrix and the target array. So here's what we're going to do. We would first things is to extract the features matrix and the target array. So here's how we do it. So let me put this. Extract the features matrix and the target array. Now, we now know that we have our data, right? So our data is, so what we're going to, we almost always represent our data as X, right? And apologies, I did mention this. Now, the target array is almost always represented as Y. So we're going to talk about these representations. So first thing is, it's the features matrix is almost always represented as X, is a capital X. So we're just going to say X underscore iris. Let's call this X underscore iris underscore data. And inside, what we're going to do is we're going to drop our target array from the data. Remember that to put it into perspective, let's just again see the first two rows of our iris data. So this is 2. So now we just want to work with these guys and then take this guy out. Now, so this is typically what you would do when building, when you want to build a model and you typically want to work with the scikit-learn API. So this is the first things you want to do after you've cleaned your data, you've explored your data, and done a bunch of things with your data. This is the time to now separate. Now, to get this done, you would now say iris data. Now, also remember that most times when this is done, it's just be called X. So I just put this X underscore iris data just to put it in perspective. So X iris data, and we are going to drop, because we only want N underscore samples and N underscore features, right? We're going to drop our target array. Right, to do that, we're just going to open here and say this is what we want to do. We want to drop species, right? And then we say axis equals to 1, because this is what we're going to do, because the 0 is our rows, 1 is our column. So we're going to drop this. Now, if we do this, we can now check the shape, so which is X underscore iris data dot shape, and see what we have here. See that? N underscore samples, N underscore features. See that? 150 rows, 4 columns. It was 5 columns before now. It's still 5 columns. If we had looked at this whole thing here, we would basically see iris data dot shape, and you see that it is 5. That's it. Now, so here what we have done is this here is the features matrix. That's what we're trying to build, right? It's the features matrix. So here, this is the features matrix for the iris data. So that's one here. Now we are now going to go to the target array, right? We're going to go to the target array, right? So that at the end, we're going to now look at how all this looks like. We're going to show you how sklearn sees this data when we start to work with it, right? Next, so here we're going to call this the target array. Now, with the target array, it's like conventional, it's called Y. A capital, this is a small letter Y, and the uppercase, it's a small case, lowercase y, and for the features matrix, it is an uppercase X, right? So that's what I'll just call this Y underscore iris underscore data. And inside, what I'm going to now do is I'm just going to say iris data, and I'll just put a square bracket. And you know, that's why we say it's almost always just a one-dimensional array or a pandas series. And here I'm just going to put species, because that's just what we're going to be predicting. And so Y underscore iris data dot shape, and what it tells you, it's it's just the samples, right? Now, for us to see this, I'm just going to use image. I have in the last session, in our introduction to machine learning, no coding, go check it out. It's the first session in our introduction to machine learning. I imported the IPython display. So here I'm just going to call image, right? And with image, I want us to see sample features. So if I put this out, so this is what we now have. We have the feature matrix here, which is X. So this is this guy. You can see that here, the number of samples, right? And the number of features. That's what we have here. And now we have our array, target array, which is just number of samples over here. So this is what we have going on, right? Now by the time we work with it, Scikit, it almost always be a NumPy array, right? At this point, you can now see that Scikit-learn can now look at it. So this is like Scikit-learn's data layout. So this is what we are predicting. Just hold on a bit. Let me. Right, this is what we are predicting. This, hold on, my annotator just turned on me. Oh no, why would you turn on me? Okay. Just hold on, guys. Let me shut this down. I don't know why my annotator turned on me, but it should be back, right? So this is what Scikit-learn data representation looks like. So here, what you're going to have is all the features, the independent arrays that was going to help us predict our target, our label. So this is what it's going to look like. Now with this, it now makes a lot of sense, right? Now, the next thing that's going to come up now, what we'll be talking about in our next session, is we're going to be looking at something called the estimator APIs. Now, the estimator API is designed, you know, it's a guide, right, that helps us understand how the Scikit-learn API typically works. It's like a principle, right? We're going to look at it in our next session, which is going to be in our third session, right? And with that, we would understand a bunch of things with the estimator API. That means every time we are going to be calling our APIs, like if we are building a regression model or a simple classification model, you would see how we would approach this. So we're going to do that, and that's going to typically make it easy for us to now go back to the beginning, which is when we say the beginning, when we have our raw data, before we do the exploratory data analysis of our data, clean up our data, try to understand our data with respect to how we want to model it. Remember, two things, really important. Remember when we talked about traditional programming, which isn't, which is what we are working on, which is not what we're doing here. With traditional programming, we have inputs. Then in the middle, we have rules. And at the end of it here, we now have outputs. But with machine learning, we have inputs, and our inputs is what this is it. This is what we're looking at, feature matrix, which is m features and n samples. In the middle, we have a model, which must be understood for us to predict our output. And our output is what the target vector over here. And so for us to be able to make use of scikit-learn, we must understand the scikit-learn data layout. So this is what it is. The scikit-learn data layout. It's important, it's ideal for you to know this. What's going on? Okay. All right. So this is it. And this will be what we're going to look at, because this is going to be our focus now. We're not going to be working with rules anymore. So the next thing we're going to do, we're going to look at the estimator APIs, right? The estimator API is designed with, guiding principles in mind. That's what's going to be in our next session, right? And yeah. So for now, I want you guys to take this in. My hope, the learning objective here is for us to figure out this data layout, scikit-learn's data layout, right? And with this in mind, whenever we analyze our data, when we have our data, we now know how to split our data. And I know we're going to talk about this splitting of data. We're going to talk about validation and future. This is going to be where this is the beginning. This is where our foundation will be starting. This is where we start our foundation, right? So do we have any questions? Oh, sorry, do we have questions? Right, so if you're watching maybe a live stream, if this is streamed live, you can drop a question in the comment section. But if you're live here, you are part and parcel of Data Science Mentors cohort. Please feel free to ask any question. You can drop a question in the in-call message area. And if you're watching a recorded session, feel free to drop a question in the Telegram channel. Right. All right.